Okay. Thanks, Guru. Good afternoon, everyone. So, when Guru asked me, talk about what are the challenges and opportunities for SDR, so I thought, okay, let me just focus on what our customers are going through and how SDN could help customer network transition. So, the focus of this talk is about why SDN for realizing the convergence that our customers are really moving towards. So that is essentially focus of my presentation. But before I start, I just wanted to introduce Ericsson. Many of you might know Ericsson. Some people think Ericsson is like a mobile handset vendor. Some people think Ericsson is a radio vendor. But in reality, Ericsson is the #1 equipment vendor for service providers such as Verizon and AT&T. It's not only equipment vendor, but also we are one of the top 5 operators in the world. We manage top mobile operators' networks. So if you combine the subscriber base that we operate networks for, we rank one of the top 5 network operators in the world. At the same time, we started managing the data centers and clouds for our service provider networks. So you can see why Ericsson is so keen on software-defined networking. So with that introduction, let me just talk about what our service provider industry is going through. It's like a perfect storm, we'll see. For the first time, the service models are changing. 10 years ago, for service providers, it's all about voice SMS. But now it's moving towards ecosystem base. With the mobile broadband and video growth, it's all about ecosystem partners. It's not just self-contained voice and SMS. You see, the business models are transforming. It's not about just customer or subscriber paying to the service provider. Right now we're talking about revenue sharing between operators and other ecosystem players. So the business models are going from simple to complex. Service models are going from just with the open device and applications, it's going towards ecosystem based. At the same time, service providers are looking at the new markets towards cloud, towards 50 billion. We call it as 50 billion, our vision, but 50 billion means including machine to machine. Today we have got 5 billion mobile subscribers. The idea is by 2020 we might have 50 billion connections. Machine to machine, healthcare, intelligent transport system, which is connected car. So think about number of connections that can grow up to 50 billion. Today we have close to 8 billion, including internet, internet subscriber base, mobile subscriber base, and others. So while we are seeing these transformations from services and business models and expanding into new markets, that is driving the way we architect the next generation network. The service models and the business models are driving the way we design the next generation network. So that's where the convergence play a role. Next generation converged networks. How we realize that? So we are looking at why SDN, how SDN can help realizing the next generation converged networks. How it can address the business drivers that our operators are looking at, as Stu LB mentioned from Verizon. It's all about economics. How can we reduce the total cost of ownership? How can we improve the revenue? How can you enable new services? How can we provide, how can we offer a programmable network where you can enable third-party applications? And how can we move from just connectivity provider to experience provider? Because user behavior is changing because of the smartphones, because of the app stores, the user behavior has been changing. So how can service provider become relevant by offering experience, delivering the applications to the users? So how SDN can help realize those business drivers, service providers? So this is a context we are working towards. With this context, what we are looking at is how SDN can help transitioning from present network to the future network. And I would like to talk about how it happens. At the same time, I would like to talk about what is the approach that Ericsson is taking to do that. What I will not talk about is protocols. That's something has been spoken enough so far. So if you really look at Ericsson, right, we have seen this. We have seen it in the 1990s, so-called split architecture. There's something called class-wise switch. If many of you know, late 90s. Class-wise switch is a monolithic device that has got signaling and data. Those days it's called data. It's not a data plane. Okay? So they're all together. It's a monolithic device. And what we have seen, and at that time, Ericsson had a #1 market share in the class-wise switch market called AXE. But we have taken a bold step in transforming that monolithic device into something called split architecture. You see? So those days it's called split architecture, in 1999-2000. So that happened moving from class-5 PSTN towards voice over IP. Okay? The same thing that we are seeing today with software-defined networking. How we decouple applications from underlying infrastructure. How we decouple the control plane from underlying forwarding like data plane. So it's a similar concept. Okay? So similar concept then, similar concepts now. How we can scale application, control and forwarding planes independently. How we can provide service velocity. Those days, I was looking at the notes 12 years ago, the same statements. Service velocity. What does it mean, service velocity? How can we introduce new services rapidly? How can we have rapid introduction of new services? Services and our applications are used with the same meaning. So essentially rapid introduction of new applications/services. The same themes between these two. But what has changed between then and now? Because of the new services and business models that have evolved with the open devices and open applications, that is really pushing the network to be more programmable. Currently the networks are rigid. There's no programmability concept. How can you enable the new applications rapidly? How can you enable third-party applications, partnered applications rapidly on the network? So that's a difference now. The second difference that we see now is a virtualization. What do I mean by virtualization? Between then, in 1999 and now, the operators built purpose-built or application-specific networks, overlay networks. One network for video, one network for data, one network for voice. I'll talk about what it means. But now with SDN, the idea is to talk, build a single network and virtualize it for multiple services. So that's the difference between then and now. So that's why Ericsson is serious about SDN, because we have seen this. However, we learned from the past 1 decade in terms of how market transitions happen, and we like to develop the feature with SDN for our customers. So with that, let's look at what it means, how the networks are evolving. Why SDN in that network transition? So as I mentioned earlier, in the past, the operators have built overlay networks. If you really look at operators network, you have got access, transport, control, and services. That's how you can categorize. Access being, base stations, these lamps, and so on and so forth. Transport being, packet or circuit transport, and control being, David Wall was talking about provider-based control, such as AAA, HSS, policy, and so on and so forth. And services being applications. That's where you see voice applications, video applications. So if you look at this layered architecture, in the past, the service providers built application-specific networks. It's a vertical integration. Okay? And then now they are trying to look at how do we provide that convergence. So you must have heard about the term called fixed model convergence. What it means is, essentially, how can I have a single network for any type of access? So now they built a single IP network for wireless and wireline access, But on the control side, still they have different control mechanisms. Although they achieved a common control using IMS/soft switch mechanism, but still they have got different ways of video delivery. There's something called DVH for mobile, something else for media flow for, in this case in the CD network by Qualcomm, and IPTV for wireline, and something else. But in the middle, we have got internet service providers such as Google. They are able to provide these applications seamless, irrespective of access type, so between any device. So looking at this, operators are saying, okay, how can I move to the next transition, next convergence, so-called ITM network convergence. That's what is known as in the industry. So what it means is that, okay, now that I realize a common network transport, how can I realize the control and services functions and virtualize them in a data center environment? So this is what the service providers are going to. So what is that SDN can do? What are the opportunities and challenges that SDN can address? Where can it address? So from our point of view, SDN challenges and opportunities lie within this transition. As Stu talked about, okay, it's not just talking about target architecture, but how can we transition from today to the target architecture? So that's where we believe SDN has a number of challenges and tremendous opportunities to solve a number of issues transitioning from today's network to the future network. So let's look at what today's network is. How simple or how complex it is. So if you look at it, you have the transport network, access aggregation, edge, backbone, the simple packet transport. Then you have got the control network where the identity and policy and all sorts of control mechanisms. That's what David Ward was talking about, provider-based controls, schemes. Then you have got applications. So the idea is that what is the impact of SDN? What are the challenges and opportunities that SDN has in terms of decoupling, control and forwarding, providing the network programmability and virtualization at transport, control and services layer. And that can take us to simple converged network. So this is what, from our point of view, from Ericsson's point of view, we are looking at what are the new business models that can influence the CDN and cloud on overall architecture. And how can we virtualize such a network and provide the programmability. So what we have done is we have taken multiple use case scenarios. We have taken access aggregation, service edge, multi-layer, as well as a cloud. Then we have done a complete architectural study. I've taken Dave Letterman top 10 questions kind of example. So what are the top 10 questions? We have started with applications. It's all about traffic characterization. What's the traffic modeling today with a hope for next 5 years? Certain traffic modeling and traffic characterization. So what does it mean in terms of adding new functions to the network? Caching, transcoding. Where do you do that in the network? So, and what are the use case scenarios based on the new functions and based on the traffic modeling? What are the use case scenarios for the wide area network and the cloud? And what are the functional scalability and reliability requirements for such use case scenarios? And what is the control and forwarding functional split for those requirements? Where do you put some of the centralized functions in the controller side? Where do you distribute, in terms of time sensitivity, to do it on a data plane or forwarding plane? And what's the economical modeling when you do this? We all know technical benefits, but what are the economical benefits to do that? And how can we how can we optimize these resources across compute, storage, and network? So how can we provide resiliency that Stu Elby was talking about in a multi-control environment to really address what carrier class is looking for? And obviously, how can we do transitioning from today to the future using SDN? So this is what the approach we've taken. And you can see how many challenges and opportunities SDN has. From our point of view, SDN is a big concept, and OpenFlow happens to be one component of it. You know, it's a protocol of choice. But we don't want, we don't want to confuse ourselves with that OpenFlow is all about SDN, but no. SDN is a concept where OpenFlow is a choice of protocol. So with that in mind, we have done two major prototypes. We have got access aggregation prototype you can see outside for wide area network with OpenFlow 1.1 and TLS implementation. We also have the cloud prototype. As Stu said, they are very much interested in elastic networking. How can we do elastic networking using SDN? So we prototyped that. The second prototype is the virtualization. So with that, I think I will end my presentation, but the idea is to talk about the SDN in an architectural transition, how Ericsson is viewing SDN to realize such an architectural transition. Okay, thank you.